Alright, so we are going to continue and do part 2 of the slope lesson, finding slope, and now we're really going to focus on finding slope from a line. But let's review quickly what slope is. And we have a really great graphic organizer here to help us kind of put a lot of different things together with slope. First of all, if we look at slope, we learned yesterday that slope is the rise over the run. Well, what do we mean with that? Well, if we look at this graphic organizer, we see here's our line on the graph. This one right here is our line on the graph, okay? And we're looking at from this point to this point. How much does the line rise up? So what is, if we could measure this distance, what is this distance right here that the line rises up? And then we write that as a fraction over the run. And the run is this distance that we have to go over to get from point to point. Okay? And yesterday I also taught you guys that slope is rise over run, which is equal to the change in y over the change in x. And again, all we mean by change is, well, what is the distance change in the y? What is the distance change in the x? And to actually calculate that distance change, okay, we do the second point. So this one right here, the y2, this point right here. Okay, this is the x, this is the y in the ordered pair. And what we do is we take this y2, okay, and subtract the y1. Okay, and once we do that, that will actually give us this distance right here. If we do y2 minus y1, that will tell us, well, how much does it rise? Okay, and then we can do the same thing for the x. If we do the x2, so the x in this ordered pair, minus the x in this ordered pair, okay, so x2 minus x1, okay, that will get us what the actual change or the rise is. Okay, alright. Okay, so let's actually graph some points and then find the slope of a line. So what I want you guys doing right now is graph these 2 points on this coordinate plane right here. Again, go ahead and graph those 2 points once you hit pause 2 so you can graph those. Okay, so you should have graphed these 2 points. In the first point, the x is -4, so that means I go left. Let me zoom in a little bit here. So that means I need to go left 4, so 1, 2, 3, 4, and then up 1. So here is my point of 4, 1, and then the other point of a positive 4, -5. So I'm going to go right 4, so right 1, 2, 3, 4, and then down 5. 1, 2, 3, 4, 5. Okay, so here are my 2 points. Now, you guys need to grab a straight edge of some kind and connect the 2 points. So if you have your student ID, if you have the edge of a book, whatever it is, use a straight edge and connect the 2 points. If you don't have a straight edge handy, hit pause, go grab one now. So I'm going to try to do this using my own straight edge. Okay, and then at the end, always put arrows because that line actually goes on forever. Okay, so now I'm going to give you some some steps for if you have a line, finding the slope. Okay, finding the slope of that line. So here are the steps. Step number 1, you guys are writing these down with me, is you're going to plot the points. We're going to plot the points. Step number 2 is you're going to do the straight edge. You're going to use a straight edge to make a straight line. And again, your IDs, your student IDs work great for that. Okay. Step number 3 is you are going to do a right, and I'll show you what I mean by these steps. Right triangle. Okay. And the key to this is stay on path. And again, I'll explain to you exactly what I mean by that. Okay. Step number 4, and you guys should be writing a little bit smaller than me in your notes, is you're going to write m equals. Okay, we're always going to write m equals rise over run. Okay, and that's going to equal, here's where you put your sign. Okay, the very first thing that you're going to do is determine your sign. Is it a positive or a negative slope, okay, that we have? And then you're going to write whatever the fraction is with the rise and the run. Okay. Finally, step number 5, you always, because we're working with fractions, you always look to see if you can reduce the slope fraction that you have. Okay, I'll give you a second to get those down. Again, if I'm moving too fast, you can always hit pause, you can always rewind. Okay, I'm going to move on. Again, if you're not quite ready, hit pause. Let's go back to this one now and apply the steps. So I've already done step 1 and step 2 with the plotting the points and the straight line. So now I'm going to make a right triangle. Okay, here is what I mean by the right triangle. Okay, we have 2 points. We need to connect these 2 points, making a right triangle. Okay, and here's how we do it. The path that I'm talking about is, see these little grid lines? All these little grid lines? We are going to stay on the path of the grid lines. So I almost went to the left there, but I have to go up a little bit further. And now if I look over across here, I am straight across from that other line. You notice I never left the path. Okay, and what does this form right here? This forms a right angle, a perfect little square there to form a right angle. Now, a common mistake that students often make is doing something like this. Okay, they'll go up like this, and they're like, I went too far, but they'll still just connect it. Don't take this down in your notes. This is wrong, and here's why. Here you can see it here. Did you stay on the path right here? No, right? You're not perfectly on the grid lines. You got off the path. Okay, so our correct one is the one with this red, where we stayed directly on the path. Okay, now we're going to write our m equals rise over run. And then let's look from yesterday. Think about yesterday. Is this a positive or a negative slope? Okay, put your pencil at the bottom and trace it up. Again, put your pencil at the bottom and trace that line up. Is your pencil moving to the left or to the right? Well, you find it's moving to the left, which you should know now is a negative slope. So we're going to write that sign in now. That way we don't forget to write it. Okay. Now that I have that, I need to count my rise and my run. Okay, so let's count. So how much did I rise up? Well, I rose up 1, 2, and I want you guys to just watch, and then you can get this down in a second. So I did 1, 2, 3, 4, 5, 6. I rose up 6 spaces. Okay. How much did I run? Okay, left and right. Well, I did 1, 2, 3, 4, 5, 6, 7. Now, do you keep going? Absolutely you do, because you're not to your point. So finally it is 8. Okay, so my run was 8. So now what I need to do is write this in as my fraction. So I said the rise, the up and down, was 6. The run, the left and right, was, and if you ever forget, just do the arrows on these. Okay, the run was 8. And now I look to see, can this fraction be reduced? And it absolutely can. Don't forget to keep your negative sign. So my slope on this one would be negative 3 over 4 once I reduce that fraction. Okay. Okay, let's go on to the next page. On the next example, you have 2 more points. I want you to graph those points and go ahead and hit pause so that you have plenty of time to graph those points, and then use a straight edge and connect those 2 lines. So go ahead and do the next example. 2 points, straight edge. Hit pause now. Okay, on our next example, it says find the slope of a line. Okay, make sure you're using cups on these. So right away I should be thinking, oh, my answer needs to be a slope that passes through the points -1 and 2 and 3, 4. Okay, I'm going to zoom in to my graph here. Alright, so you should have already had these points, but -1, I go left 1, up 2. Okay, and then 3, 4, I go right 3, and then down 1, 2, 3, 4. Okay, so here are my points. I take my straight edge now, which you should have already done this. Take my straight edge, connect the two, and your line should be a little bit bigger on my computer screen. It's hard to make a longer line. Okay, so now that I have these, I can go ahead and connect these 2 points, making a right triangle. So boom, and then I'm looking across. Oh, now I'm at the same level, so now I need to go straight over. Okay. Now, if you went a little bit too far, like if you went up and you're like, I went too far, okay, you can simply erase it. Okay, so if you went too far, you can erase it. Now I'm going to count my rise and my run. So I'm going to start down here. I have 1, 2, 3, 4, 5, 6. The other thing I sometimes like to do is write that this is my y. My up and down is always my y axis, right? Because that's the y axis, the up and down. My left and right movements is always my x. Okay, so then left and right, I need to go 1, 2, 3, 4. So my x is 4. Okay, so now I'm going to write m equals rise over run. Okay. And again, if it helps you, put the y, put the x as a reminder. Okay, because a common mistake, you guys, on this is to get this far and it's to just flip them around where you put the x value on top and the y on bottom, and that's just a silly, silly mistake that you can definitely avoid. Okay, now if I look at this line, I can look at it and see it's actually I want to ask you, is it a positive or a negative slope? Okay, and to determine it, quickly put your pencil at the bottom of the line, trace it up. As you trace it up, you realize your pencil is going a little bit to the left, which tells me it is a negative slope. Okay, and then my rise was 6. My run was 4. Okay, and if I reduce this, it can reduce to, move this over. Okay, if I reduce it on my calculator, it might, if I do it on my calculator, it might give me a mixed number. It might give me something like this, -1 1/2. Okay, this is a key point. Okay, when we are working with slope, we never do mixed numbers. Okay, so we never do mixed numbers. So no mixed numbers. And we'll see in a later lesson why, because you can't do a rise and a run when you have 3 different numbers here. So make sure you keep your answer in proper, and if we reduce this one, both of these are divisible by 2. So divide by 2, divide by 2. My answer is a -3/2. That is the slope to this line on the graph. Okay, let's go on to the next example. Okay, it says find the slope of this guy. Okay, so alright, this is a fun one. So let me zoom in a little bit. Okay, once we made the graphs with points, we actually had two dots, 2 points that were already there. Okay, now we have a line that doesn't have any points on it. Okay, so the first thing that we're going to have to do is find points that are on this line. Now when we do this, I want you to think if you've ever played a video game where it's like a shooting video game where you have a gun, and especially like a sniper rifle, and you like zoom in, right, and you see the crosshairs through that scope. Okay, once your target is right perfectly on those crosshairs, that's when you know you're good, right? When the point is perfectly on the crosshairs. We're doing the same thing when we think about this, except our crosshairs here are all of these places, all of them on here, where the coordinate planes, the lines intersect. Think about those as your crosshairs. We need our line to perfectly cross through those crosshairs. If it's a little bit off to the side, okay, like the second one, that's not where a point's going to go. So if we look at this one, if we start down here at the bottom, okay, if we look at this point, let me change the color here to red. If we look at this point right here, okay, this only crosses through one line, but not two. Keep going up. Here is one. See this point right here? Where the line perfectly crosses through both of the lines on the graph. That's how we know we can put a point right there. So go ahead and get that point in. Okay? And keep going up. If we look at this next point on the line that crosses through, nope, it only crosses through one of the lines on the graph. This point, nope, again only one. This point, it's close, but not quite. It doesn't quite cross through both. This, here's another point. Again, think about crosshairs that perfectly crosses. Okay, this point, nope, close, but not quite. This next point, nope, close, but not quite. Same here, close, but not quite through both. Finally, we have this one that crosses through both. Okay, so now we have our 3 points. Now we can make our, basically think of them as stairs. Okay, where we go straight up. Remember, right triangle, straight up and straight over. Okay, then from this point, start again. Straight up and straight over. Okay. Now, I'm going to find the rise and run for both of these stairs. Okay, so for this one, it's 1, 2, 3, 4. So my y equals 4. My x, there's just 1 here. My x is 1. Okay, now if I go to this one, same thing. I'm counting 1, 2, 3, 4. 4 and 1. Okay, so I'm going to write my m equals rise over run. And that is going to equal, if I look at this, again, it's a negative slope for the line because it goes up and to the left. So it's a negative slope. Okay, and then my rise, my y is 4. My run is 1. Okay, so my final answer would be m equals negative 4 over 1. Now, do you have to leave it as a fraction? No, you could say, oh, my slope equals negative 4. Okay, either one of these would be fine for answer. This one can't be reduced anymore. You could just write it as negative 4 though. Okay. Okay, let's go on to our next example. And our next example says plot the points negative 2, negative 1, 2, and 3, 2 on the graph. So go ahead and hit pause. Why don't you guys plot the points for both of these, okay? Plot the points for example number 3 here, and also for example number 4. Go ahead and hit pause and do both of those, and then when you're done, you can, connect them with the line. And when you get the line for both, go ahead and hit play again. Okay, by now you should have these graphed. Alright, let's look at this first one. So I graphed this first one, and if I look at my line, right away, when I look at these two lines, okay, right away, whenever you see a straight up and down, a vertical line, or a straight line going left and right, a horizontal line, okay, light bulb should be going off saying, okay, these lines are a lot different. Okay, I have to remember some different things about these. Okay, so first of all, we're trying to find the slope, right? Think back to when we talked about slope in the previous video lesson. Anytime we have a line that is going straight left and right, think about the slope for that. And again, whenever you think about slope, think about how much fun is this to go sledding on. And the answer is, this is 0 fun. Okay, so right away, I know that the slope of this line is 0. Okay, but I want to show you the math that proves it. Okay, so if we look at this one, okay, again, if you were going to do the rise and the run, okay, between 2 points. So can I make a right triangle on this one? The answer is no, right? I can't just like go, okay, and don't do this in your notes because I just want to show you what students often do. They're like, oh, there it is, okay, but this doesn't connect to the 2 points. The quickest way to connect between 2 points would just be to do this line right here, right? Okay. Think about the line, the second line that we just made. What's the rise on that? Does it ever, this line right here, Does it ever go up and down? No, it never goes up and down. Well, what's the run? Well, the run on this one would be 4. If we counted 1, 2, 3, 4 between, it would be 4. But we could also pick points like here and here, and then the run would be a much bigger number. Maybe, I don't even know what that one is. It doesn't really matter. We could say like it's 0 over, let's just say 10. Okay? We could pick points out here and say it's 0 over, 15. Okay? Doesn't matter. Why? Because if you do 0 divided by any number, so if you do 0 divided by any number, you're always going to get 0. And this math right here with the rise over the run proves why a line that is horizontal always has a slope of 0. Okay, so get this down. This is a key point with horizontal lines. Okay. Now I want to show you something else really cool. Okay, look at the ordered pair. Okay, what do you notice about the ordered pairs? Both of them for the y value have the same number. Okay, both of them for the y value have the same number. And remember, y is the up and down, right? If it's the same number, is that line ever increasing, going up, or going down? And the answer is no. That y value is always staying at the positive 2. Okay, so the smart cut for this is, okay, lines with a slope of 0. Okay, lines with a slope of 0 have the same y coordinate. Oops. The same y coordinate in every ordered pair. Okay, get that down. Okay, if you're not done writing that, you can always pause it and get that down. Okay, again, if I go up here to this, they have the same y coordinate in all the ordered pairs. I could write a ton of other ordered pairs for this one. And basically it comes down to I can write any number for x because remember over here, this line goes on forever. Okay, I could write x is 20 all the way out here. Okay, so you have any number for x, and on this particular line, the y is always going to be 2. Okay, now let's go down and look at this one. Okay, I'm going to graph this really quickly. Okay, on this one, here's what the graph looks like. Again, right away I should be saying to myself, oh, it's a vertical line. There's something different about the slope. Okay, remember back to yesterday. And again, whenever we're thinking about slope, think about sledding. Okay, think about sledding down this one. Here's my guy. He's about to take off and go sledding. What's going to happen once he hits this line? He's going to fall off, and unfortunately, he is going to die. Okay, how much fun is it to sled on a vertical line? You cannot even define. You can't even define how much fun it is. Therefore, we say it is undefined. Okay, we should know that from the other day. Now, let me prove it to you using the math. So get this down as well. M equals rise over run. Okay. Now, we don't really have a sign for this one. Now, think about the rise. Does this line ever rise up? And the answer is clearly yes, it does line up or rise up, right? And this, with our 2 dots here, it rises up 1, 2, 3, 4, 5, 6, 6. Okay. Now, does it ever run? Does it ever go left and right? The answer is no. It never goes left and right. Okay, so the run is 0. Okay, again, you could pick any other 2 points along here and say, oh, my rise is 10. What's my run going to be? 0. Do this on your calculator. Do 6 divided by 0, 10 divided by 0. And you're going to get an error message on your calculator, right? Okay. Again, you cannot do a number divided by 0. That's why we say the slope on this is undefined. Okay. Again, with these 2 lines, with the horizontal slope equaling 0 and the vertical slope equaling undefined, You really have to memorize these and understand why it's 0 or undefined. Okay? The key points again, for horizontal lines, the 0 for the rise and the run will be in the numerator. Okay? For vertical lines, the 0 and the fraction will be in the denominator. Okay? Alright, let's go down and last two examples for this lesson. Let's look at these two. Okay, it says find the slope of a line. Okay, right away I should be thinking in my head, oh, m equals rise over run. Whenever I see the word slope, that's immediately what goes through my head that passes through these 2 points. Okay. Now, before we even graph it, okay, I want you to look at these 2 points and think about these 2 points in relation to what we just talked about up above. And try to make an observation. Okay. I'm going to give you a hint if you didn't notice it already. Okay. They have the same what? Okay, these have the same y values in the ordered pairs. What do we know when the y value is the same? Okay, we know that no matter what x it is, in this case the y value is 5, right? No matter what x it is, it could be x of -4 in that first one. We're going to go up to where? -4 and up 5. Did I do that right? 1, 2, 3, 4, 5. Yeah. Okay. For this other one, it's going to be right 1, up 5. Okay, any ordered pair, we're going to be going, excuse me, we're going to be going up to 5. What do we notice about the line that we're starting to form? Well, it's going to be a horizontal line, which I know the slope is of a horizontal line. It is 0 fun to sled on, m equals 0. And again, the smart cut is we should have seen that without even having to graph it, because the y values were the same. Okay, if the y values in the ordered pair are the same, and it only gives us 2, we know that it is going to be a horizontal line. Okay, let's look at this one. Same thing, right? What do we notice right away? It says find the slope. Okay, y values are the same, so what does that tell us? That tells us it is going to be a horizontal line, meaning the slope is 0. Okay. Now, what if it gave you something like these 2 ordered pairs? So let's do another example. -5, 2, and the other one is -5, 10. What do you notice about these 2? Well, the x's are the same. And if we go back up here, okay, when the x's are the same, we know that the slope is going to be undefined. Let's actually get that right here. So slopes that are undefined will always have the same x values. Okay, and it's going to look something like this. It's going to be the same x. So let's just say like 5 and a number. And then the other ordered pair is going to be 5 and any other number. Okay, the same x. Okay. All right. We're going to have some practice problems for this, but that concludes the lesson on finding slope from a line.